Okay, in this video, we're going to be talking about dot products and some of the applications of what a dot product is. Now, we've talked about other operations in previous videos, but this is a new operation. It says, recall that vector addition and subtraction are operations that result in a new vector. The dot product, however, is another vector operation, but it does not result in another vector. It results in a scalar or a number. Other names for a dot product you can see down here in the notes. Sometimes they call this the scalar product or the inner product, so the exact same thing. Here's how you find the dot product. If you have vector a1, b1 and vector 2 or vector w, a2, b2, the dot product v times w is defined in the following way. V times W will equal A1 times A2 plus B1 times B2. So you'll multiply your A's together, you'll multiply your B's together, and simply add the answers together. Let's find some dot products with some vectors. Let me zoom in here. So our first one, to find P, we call it P dot Q a lot of times, P dot Q. We're going to multiply our A's together. 5 times 1 is 5. Plus, multiply your B's together, and it gives you 18. 5 plus 18 is 23, and that's it. Dot product of these two vectors is simply 23. To dot product these, you're going to multiply your first two numbers. 0 times negative 2 is 0, plus 4 times negative 4 is a negative 16. 0 plus negative 16 is negative 16. So that's R dot 6, or R dot S. Next one, now we're in, written in linear combinations on these. Let's find V dot W. We're going to do 7 times negative 1, which is negative 7, plus 8 times negative 9, which is a negative 72. Negative 7 and negative 72 is a negative 79. And number 4, same thing, C dot D is equal to 3 times negative 2, which is negative 6, plus negative 7 times negative 2, which is 14. Negative 6 and 14 is simply 8. And that's all you have to do. Okay, now we're going to get into the actual applications of these. And let's talk about orthogonal. The word orthogonal simply means perpendicular. Those two words are interchangeable, so don't get anything confused. If two vectors are perpendicular or orthogonal, then their dot product is equal to 0. Vectors with a dot product of 0 are also described again as orthogonal. So the next ones are simply determine if the vectors are orthogonal. And again, the way we're going to do that is we're going to find the dot product. If the dot product is equal to 0, then they're perpendicular. Multiply to find m dot n. We're going to multiply 3 times negative 28, which is negative 84, plus 7 times 12, which is positive 84, which gives us 0. And we could graph these two vectors, and we will find out that they are perpendicular. And I just sketched out a little graph of kind of what this would look like, and you can see if they are perpendicular, then they would form a right angle right there. Next up, are these perpendicular? Let's find G dot H. Multiply negative 3 times 40, and that'd be negative 120. Multiply negative 2 times negative 15, that is a positive 30. So therefore, negative 120 and positive 30 gives you negative 90. So therefore, no, these are not perpendicular or orthogonal. Number 7. Again, these are written as a in the IJ form, or as a linear combination. So again, multiply your x components together, negative 5 times negative 1, to find the dot product is a positive 5, plus multiply the negative 1 times a negative 5 here, which is also a positive 5. So when you add 5 and 5, gives you 10. So therefore, again, no, these would not be orthogonal. And number 8, 12 times 9 gives you a 108, plus negative 18 times 6 is a negative 108. Positive 108 plus negative 108 is 0. So therefore, yes, these two vectors would be orthogonal. Okay, next up, we're going to go through a lot of your properties of dot products. And it says if V and W are vectors, then, and K is a real number, then. And here's a list of your properties. First off, dot products are commutative, which means that vector V dot vector w is the same thing as vector w dot vector v. So dot products are commutative. Okay, property 2, dot products can be distributed. Vector v, or excuse me, yeah, that's right. Vector v times vector w plus, now we're going to have to come up with a new vector here because they didn't give me enough vectors up here. So we'll call it vector x. The dot product of this, you can do vector v times vector w plus vector v times vector x. So you can distribute. Now the next property is kind of a mixture of commutative and associative. Let me go ahead and write it down. And there it is. Now a reminder that k is a whole number. So if you're asked to multiply a whole number times a dot product, you can actually find the dot product first, then multiply, or you could multiply the k times one of the vectors and then find the dot product with the other vector, or you can multiply k with the other vector and then find the dot product. It doesn't matter what order that you multiply those in and which ones you multiply together, as long as they're all get multiplied together. Okay, the next one is your zero product property. 0 times a vector is going to equal the 0 vector. And then the last one, and this one's pretty cool. If you dot product a vector with itself, it's going to be the same thing as the magnitude of that vector squared. So that one's going to come in handy a little bit down the road. So let's go ahead and jump to the next section, which actually builds on that, the magnitude using dot products. So since we just found out that if the dot product of a vector in itself is equal to the magnitude of the vector squared, then that means the magnitude of a vector is going to be the same thing as the square root of v dot v. If we just move that square over by square rooting, that's what we have. So we can actually use the dot product to find the magnitude. So let's try to do that, the magnitude using dot product. So use the dot product to find the magnitude of each vector. So we're going to use this right here. To find the magnitude using dot products, we can dot product and just square root the answer. So we're going to dot product a vector with itself. To find the magnitude. The magnitude of vector r right here will equal the square root of the vector 1024 dotted with itself. Now I'm not going to write down all this information every time. I'm just showing you that's what I'm doing. So to dot product it with itself, we're going to do 10 times 10, which is 100, plus 24 times 24, which is 576. So you get the square root of 676, which is 26. Now again, the other method for magnitude, I do want to remind you of it real quick. The other method that we had for magnitude, finding the magnitude, which is probably easier actually, is just the square root of 10 squared plus 24 squared. And you can again see we multiply 10 times 10, which is the same thing as that. We multiply 24 times itself, which is the same thing as that, and we added it, so you would get the exact same answer. The next one, dot product of it with itself. So the magnitude of A will equal the square root, and let's go ahead and take that dot product. Multiply, I'm just going to list it again right here, negative root 7 and negative 13. We're going to dot them. A negative times a negative will be a positive. Root 7 times root 7 is 7. Negative 13 times negative 13 is a positive 169. So therefore, we get the square root of 176. Which can be split into the square root of 16 times the square root of 11. So there is your magnitude. And again, the magnitude is the length of that vector. Let's do a couple more. Let's dot product this with itself and then take the square root to find the magnitude. So that's going to be the square root, dot product with itself is going to be negative 2 times negative 2, which is 4, plus 18 times 18, which is 324. So therefore you get the square root of 328. And we can split that into the square root of 4 times the square root of 82. So therefore 2 root 82 is going to be the magnitude of that vector. And one last one, the magnitude of k can be found by doing the square root of 14 times 14, which is 196, plus 3 times 3, which is 9. So that's going to be the square root of 205. And that will not simplify. And each and every one of those you could have written also in decimal form. Now, one of the main applications, though, of dot products is right here, finding the angle between two vectors. If theta is the angle between two vectors, so you see here in the picture you have vector v and vector w. If we let theta be the angle between those two vectors, then we can find that angle by using the following formula. The cosine of theta, or the cosine of that angle, will be the same thing or equal to v dot w. We're going to dot product the two vectors, and we're going to divide it by the product of their magnitudes. And then we could find the inverse cosine, and that's going to tell us the angle between the two vectors. Now, I do want to remind you that there actually are two angles between these vectors. You have this angle here, the smaller, and then you're going to have an angle here. So you're going to have two different possibilities for angles between these two vectors. Okay, if an angle between the vectors is 90 degrees, then the vectors are going to be perpendicular. Or again, we learned another name for that a while ago, and I'm going to put it here as well, or orthogonal. And I do want to remind you that the way that that's going to happen is if the dot product, I'm going to put here dot is equal to 0. If you find the dot product is equal to 0, then you're going to have that situation. But go back and look. Well, if the dot product is 0, that means this whole thing over here is 0. So you'd have the cosine is equal to 0, which means that's a 90-degree angle if the cosine is 0. If the angle between the two vectors is 0 degrees or 180 degrees, then that means the two vectors are parallel. So if you have two vectors, maybe one of them's right here and the other one's right on top of it, those two vectors are parallel. Or if the other vector points in the opposite direction, those two vectors are parallel to each other. So 0 degrees or 180 degrees, then you have parallel vectors. So number 13, let's go ahead and use our formula and let's find the angle. Okay, so let's find the missing pieces of our formula. First, we're going to have to find u dot v. So to find u dot v, again, what we're going to do is multiply 8 times negative 7, which is negative 56, plus negative 7 times negative 3, which is 21. So that's going to give me a negative 35 for u dot v. Next up, let's find the magnitude of u. And we do so by doing the Pythagorean theorem. That's going to be the square root of a squared plus b squared, which would be 64 and 49, which is going to be the square root of 100, and 13. Next up, let's find the magnitude of v. And that handwriting looks horrible. Let's see if I can draw that without shaking. Not much better. That's going to be the square root of a squared plus b squared, which is 49 and 9 there, which would be the square root of 58. So now let's plug everything in. You have the cosine of theta is equal to negative 35 was u dot v over square root of 113 times the square root of 58. Now from here, it's really all calculator work. It'd be kind of silly to simplify anything, to multiply anything together, because you're going to have to just take the inverse cosine anyway, and you're going to have to use the calculator for that. My advice, though, when you do type this in, make sure that this bottom is in parentheses so that you're dividing negative 35 times that product, because if you don't put parentheses around the bottom, you'll do negative 35 by just this. You'll divide it by just that, and then you'll take that answer and multiply by root 58, and it'll give you the wrong answer. So make sure parentheses around the bottom. Find the inverse cosine, and if you want to deal with reference angles, that's fine. Or if you just want to leave the negative in there, it'll give you the answer that you need. Your theta is going to be 115.62 degrees. Now, there are two answers there. If you wanted to find just the reference angle, I'll show you what actually happens there with that second answer, because cosine is negative right here. Where is cosine negative? Cosine is negative in the second quadrant and in the third quadrant. So you have two possible answers here. So 115.62 is only that second quadrant answer. If you do the cosine is equal to and just find your reference angle, you're going to find out that your reference angle is going to equal 64.38 degrees. And again, when you subtracted that from 180, that gave you this second quadrant reference angle. When you add 180 to that, it also gives you the third quadrant answer, which is going to be 244.38. And you might be asking, well, why do I have two different answers there? What's the reasoning for two different answers? Well, if you have two vectors, let me just kind of sketch a drawing. You had two vectors. Let's say there's one here and there's another one about right here, and the angle between them was 115 degrees. Well, that would be this angle. What about this angle between them? That would be the other 244.38. But now, most of the time, they are looking for the smaller of the two angles, but that does give you both answers. But this is the answer that they're looking for. Okay, the next one. So the cosine of theta is equal to the dot product on top. So let's find the dot product of these two vectors. 0 times negative 3 is 0, plus 6 times 5 is 30. So the dot product is going to be on top, 30. The magnitude of the two vectors go on bottom. So the magnitude of your first vector is going to be the square root of a squared plus b squared, which would be the square root of 36, which is just going to be 6. And then the times the magnitude of the second one, which would be the square root of 9 times 25, which is the square root of, I believe that would be 34. So 6 times the square root of 34. This is going to be an acute angle, I know already by looking at it, because this is a positive value. So you're going to end up with a first quadrant answer here. So we're going to type this in. We're going to find the inverse cosine, and that's going to tell us that theta is equal to 30.96 degrees. And again, you could use that reference angle, and you could find that fourth quadrant answer as well, which would be the other angle between the two vectors. Number 15, the cosine of the angle between the two vectors. Let me zoom in just a little bit. On top, let's find the dot product. So you're going to have 6 times 9, which is 54, plus 7 times negative 6, which is a negative 42. So that's going to be a 12 on top. Then on bottom, you have the magnitude of the two vectors. The magnitude of your first one is going to be the square root of a squared plus b squared, which is 36 plus 49. That's going to be the square root of 85, times the magnitude of the second, which would be the square root of 81 plus 36, which is the square root of 117. And again, that's a positive value. When you type that into your calculator, there's no negatives there. So therefore, that tells you again that your angle is going to be an acute angle. So move the cosine over by taking the inverse cosine of that answer. And that will tell you that theta is equal to 83.09 degrees. And the next one, number 16. Again, step number 1, cosine of theta is equal to the dot product on top. So let's find the dot between P and Q. That'll be 1 times negative 3, which is negative 3, plus 2 times negative 6, which is a negative 12. So your dot product is negative 15. Over the magnitude of your first vector, which is the square root of 1 squared plus 2 squared, which is the square root of 1 plus 4, which is the square root of 5. Times the square root of the second, the magnitude of the second, which will be the square root of 9 plus 36, which is going to be the square root of 45. Plug all of that into your calculator, and something odd actually happens. When you plug that in, you get the cosine of theta is equal to negative 1. So then you have to go again, that's a quadrantal angle. Where is cosine equal to negative 1? That'd be right here at 180 degrees. So therefore, theta is equal to 180 degrees. And again, if your theta is 0 or 180, these two vectors are actually parallel vectors. They would be pointing in opposite directions in this case because the 180 for the angle, but these vectors are parallel.